Okay.
Hi.
Yeah, we're live.
Okay, hello. So Elon, we're live.
We're live.
I guess
Anyone can comment in the thing.
Hey guys, thank you much for taking the time. So please feel free to ask any questions you may have in the chat box. Yeah, happy to answer any items that may come up. To start with, I think that we're going to take some questions that were sent to us earlier. So we've made a list. The first question is Bitcoin got the limelight because out of many other reasons, it's a decentralized project. Do we think that the future of blockchain project lies in ones which have CEOs or community-run projects or do I think community-run projects will be more successful? If I do think community-run projects will be more successful, would we go this route and handing our baby over to the community to take it further after the initial phase? So my answer to that would be essentially that I agree with that. As in, Satoshi, for example, wasn't a CEO. I actually find it kind of funny, the whole CEO thing. I think it's a lot of formality that on a personal note, I don't really appreciate, but essentially, at this very early stage of the project, you do have, an entity that's been running it. And obviously once we go to our mainnet, and we feel that the code is at a mature level that we would really want people to continue to develop it further in that direction. We're very much going to be welcoming the community to come in and to build it out further. And, but we need to have everything set up straight, have the right tutorials, et cetera, to really have it become a more community project. So Nathan, would you like to take the second question?
Yep. Can you list 3 or 4 different real-world use cases for Zen protocol? So the natural one that we're doing right now are derivatives, or products that are based on existing things. These can be cryptocurrencies or things that live on blockchains already. So you could have the ability to short a token, or to have a futures in a token, or to have a swap on a token, which means you exchange something based on what it does continuously. And that's one case. And other cases coming down the line are real assets based on things that happen out in the real world, linked to our blockchain with data feeds, oracles. There's some stuff that we're already looking at doing in that direction. And the third big thing that comes to mind is decentralized markets. Being able to trade these things in a system that doesn't depend on a trusted third party, but that is still secure and efficient. And those are the things that come to mind immediately.
Excellent. So when the next question that we had was, what are the real world competitors? What are the real competitors that Zen Protocol has, and what are the unique service propositions? Essentially, what makes us different than all the other people out there? So essentially, the way I see it is that, today, you have this kind of situation where all the banks that are doing financial focused blockchains are all private. So there's no real, new thing here. It's just an update to the database. And a lot of these decentralized projects, I feel that, there's a lot of hype and froth in the space, but essentially they're not necessarily doing what a blockchain is designed for, which is obviously the reason Satoshi invented it in the first place, which is finance. So, or essentially the ability to move around assets based on some, set of conditions. Bitcoin does that for like one asset under one set of conditions. And we're trying to enable, rather than try to be money, essentially, we're trying to enable just a generalized financial system where you can move around assets without requiring a third party. So I don't see a lot of real competition in that space. The projects I do see are ones that are like, let's say, doing one kind of component, but not the full end-to-end service in it. So what we are providing is essentially like a vertically integrated, a complete solution, everything you need to actually to replace your bank. Ash, you want to take the fourth one?
Yeah, sure. So that'll be, will we be hiring more people to be part of the development team? Or maybe we think we have necessary resources already to deliver what we're planning to achieve. We do intend to hire more people into the development team. We would like to grow. We would like to have more people developing this. Obviously, this is a very far-reaching project. We have a very lofty goal. So having more people means that we can achieve that better. It also means that we can achieve auxiliary goals, like having cross-platform implementations, wallets on mobile and web. Essentially, the more developers we have, the more we can do. So we certainly intend to grow the team that way.
Yeah.
Yeah, I'd like to add that also. Yeah, beyond just increasing our development team, I think it's very important, to also be providing services to essentially to also on the non-technical side to make it easy for companies to interface with. If a company now decides, am I going to integrate with Ethereum or Zen, the choice is essentially going to come down to how easy is it for me and how much support am I going to have in that process. So I think that's a thing that we definitely need to allocate a lot of resources to. So for the fifth question, is essentially one that I hear often, is it's asking us about the price, our token sale price. So essentially the question is this: people that don't own Bitcoin and want to take part in this project can't buy tokens because the Bitcoin to US dollar rate doubled. Why did you decide to sell on a fixed 0.000284 BTC per Zen token and not on a fixed dollar rate? So the reason is essentially, and I understand this is a confusing question, but essentially, let's say someone gave us money a month ago, and if we counted it in dollars at the time it was received, then what would have happened to that guy is he would have lost out on a lot of the value. So essentially, you'd have someone who gave us a Bitcoin today and a person who gave us a Bitcoin a month ago, but the guy who gave us a Bitcoin a month ago would be very much hurt relative to the person who gave us a Bitcoin today. And you want to both kind of relax people that they can give you money without being afraid that the price of Bitcoin will go up. And the way to do that is by pricing things in Bitcoins, not in dollars. So essentially the rationale here was, we did want to have a dollar, we did want to get a dollar amount, but we did want to, obviously take it in Bitcoin, and we didn't want to hurt people who who gave us Bitcoins earlier. So rather than raise, let's say, 7,000 Bitcoin, which was like the plan, a month earlier, we kind of cut that in half 2 days before the sale. And essentially what what we just need to make sure is so that, you don't have a situation where all of a sudden we can't essentially count how many tokens we're going to be selling. Because if the price is always fluctuating, there's no way to determine that. So essentially the short answer that I would like to say, which I really want to make clear, is don't think of it anymore as if we're raising, $2 a token or whatever it is. Just think of it as, like all the other ICOs, Ethereum, et cetera, they all did it, on a Bitcoin cap. So, we're raising essentially on a nominal market cap, not real, but a nominal amount of tokens that are being sold is, 3,400 BTC. Just think of it that we're taking 3,400 BTC and that's it. Yeah, just wanted to clear that up. Now, before we go on to our list of questions, I think that we should start addressing the questions that were sent in the chat. So Dole is asking a question. Nathan, you want to?
Where is Dole's question? 1 second.
So,
I see. Is this hi, the project sounds amazing? Yes, this one?
Yeah.
Okay. Hi, the project sounds amazing. I just want to know, thank you, by the way. I just want to know if the 12 million Zen coins is the final amount. Okay, so that is the amount that we are selling. and there will be another 8 million on top of that at the Genesis block for 20 million total. And then there'll be mining and decentralized issuance. And that's going to take us up to 100 million in like several decades time, like dozens of years away. It halves like Bitcoin does. And when I say decentralized issuance, I mean mining plus. So if people want to have a development fund, then they can use the mechanism that we're providing to actually allocate to that development fund. But it's mining and these other things not under our control, but issued on a fixed schedule over time. Anything else,
Excellent. Thank you. So essentially, okay, next question by John Gold is, hey, your project sounds very, very interesting. I got 2 questions. Number one, as Nathan said, thank you. The first question here is Zen a sidechain? And if so, how does it affect the blockchain? The second question is if you can shed some light on the difference between Zen and Ethereum for a non-technical person. Thank you very much. Sure. So is Zen a sidechain? That's a hard question because I recommend there's an article out there called My Sofa is a Sidechain. The definition of sidechain is one which is quite lucid. And, you know, it's very hard to define exactly what is and what is not a sidechain. I think that the normal definition essentially says, you know, you're going to have a cryptographic peg, which is going to be merge mined. So those are the main points. And essentially, thank you, Elon, for putting that link there. So we're not essentially the SPV pegs don't really exist. So, you know, no one really has a real true sidechain yet. What we do have essentially though is that a kind of feature which is orthogonal to a sidechain, and I think maybe even better because, you know, with a sidechain, you're taking your Bitcoins, you're turning them into sidechain coins, then you're doing whatever you want to do on the sidechain, then you're coming back to the Bitcoin chain, then you're like switching it back and coming into the Bitcoin chain. Contracts. So for example, let's say I'm writing, you know, an option on a contract. I can accept payment for the premium. I can write in my smart contract, if I receive money to this Bitcoin address, then so if in the event that I receive money to this Bitcoin address, then what's it?
Sorry about this, guys. Just bear with us until we get our technical issues fixed.
Can you hear me? Okay. Wait, I think Ash is coming back. Reset? I'm going to try restarting, okay? Just a second. while we're trying to. Okay, two is good. All right.
Okay, so in the meantime, maybe we should answer some different questions.
Yeah.
So, is it true you were attacked and an anonymous group helped you? It's more or less impossible to know if an anonymous group is helping you. It's not really. By the very nature, if they're anonymous, you don't know who's helping you.
The question is, were we helped?
Okay, so I think
maybe.
One sec. Okay, let me answer a few questions. Sorry, going back to the thing, just because I want to, in order of continuity, I also don't know exactly where the viewers got cut out and where it was just me getting cut out. Point is, essentially, are we a sidechain? Answer to that is, we're different from a sidechain in that, you don't have to turn your Bitcoins into sidechain coins and then do the operation you want to do, and then take your sidechain coins and turn them back into Bitcoins through the peg. With us, you can just do a transaction, and that transaction can directly interact with a smart contract written on Zen. For example, you could have a smart contract in Zen which holds collateral. For example, let's say a credit default swap kind of thing that says, in the event that I send this message to Kraken and Kraken doesn't send this BTC to my address, then, I can liquidate money that Kraken holds. And this kind of scenario, this contract would observe, the transactions which happen on the Bitcoin blockchain. But it's not necessarily that the transactions happen on the Zen blockchain. It's just that this Zen smart contract observes Bitcoin's blockchain. So that's to question number one, if Zen is a sidechain. To question number two, is essentially, how is Zen and Ethereum different? For a non-technical person, essentially what I'd say is that Ethereum was designed to be like a playground of building any sort of decentralized application. So they want to be very generalized, very flexible, very programmable, not necessarily focused on a specific use case. Whereas we have like a target market. We're saying, okay, this is the thing we want to do. We both in all aspects of how we operate, whether it's our technical architecture, which we feel is far superior, how we communicate internally with businesses, the design of our product, et cetera, et cetera. So those are the answers to those two questions. Thank you for your patience with my shitty connectivity. Yeah, sorry, back to Nathan and Ash.
Yeah, so Ren asked, are you as secure as Ethereum? It's an interesting question. Is Ethereum very secure in the first place? You've seen frequent problems with Ethereum. You had the DAO hack last year. You've had two major issues with parity this year, all of which caused multi-million-dollar losses. Recently, I think it was Parity who did a security audit of the Solidity compiler. They found quite a few low-level issues. Issue ranking is more or less irrelevant in security. Like a bug is a bug. Sometimes they combine to make bigger bugs. So Ethereum security isn't really great. We're aiming much higher than that. So most of the problems in Ethereum, the bigger ones, aren't really to do with compilers or implementations. It's to do with smart contracts themselves. People have a lot of difficulties writing secure smart contracts for Ethereum. So you've had other people propose the use of formal verification for smart contracts, and the way Ethereum works, it's designed to have a very low-level programmable interface, and it doesn't lend itself very well to formal verification, which is why people aren't really doing formal verification much on Ethereum smart contracts. We're designed to facilitate formal verification very easily. We use a programming language that we designed, ZFStar, which is designed to make it very easy to formally verify user smart contracts. It's also generally highly secure language. It's very, very difficult to write low-level bugs when you're working in a high-level language. So yeah, I'd say much more secure than Ethereum.
Our attack surface is a lot smaller. This world computer, you have to think about everything that can go wrong with moving around data in a computer or passing messages between contracts. If you design a blockchain or a consensus system to understand what an asset is and what it means to send a message or to have a write, then it's a lot harder to make these bugs, as Ash says. Also, our code, it doesn't actually get passed around in low-level form. It gets passed around in the same form that you write it in. So we don't have this problem whereby you can have stuff that looks fine at the top level, but at the low level there's problems because you got something wrong, or rather the people designing it got something wrong.
I'd just like to add in here, it's like even things that, beginning in the project, at least I didn't see as a security highlight. I later saw how just by designing something specifically for finance, you avoid these errors that aren't necessarily obvious. An example of this is recently, the loss of all that money that happened due to some guy erasing the multi-sig contract in Ethereum. Essentially, so there were a few things that happened there, right? One was the fact that, contracts depend on other contracts. And most importantly, I think that what I was really positively surprised about is the fact that, in Ethereum, the way that contracts are identified isn't like from their hashes. And essentially that the way that, contracts can, once you delete a contract, you can't reactivate it. If you could have reactivated the contract, then all that money wouldn't have been lost. And that's something that's very trivial. We implemented like active contracts as a scalability thing, not as a security measure, but it's just nice to see that those like little nuances that all of a sudden pop up and you say, just because it was thought specifically for assets makes it also more secure as a byproduct. So I think just the general focus on being built for one specific thing is a huge advantage. Yeah, that's all I had to put in there. So the next question is, thanks. If you guys don't sell 12 million by the 31st December, how will it affect our plans? So, I don't think it will, let me put it this way. It won't affect our plans because, number one, we're very determined to get it done. I mean, obviously, as budgets change, our constraints change, but either way, we're going to deliver on our promises. Maybe you'll have more money, maybe we'll have less money, maybe we'll be able to allocate more capital to projects, and maybe not. But essentially, at the end of the day, no matter what, we're going to get the thing done. So yeah, I don't see any material effect on our plans. Ash, would you like to take the next question?
So the next question, could you give a general explanation of what formal verification is and how it creates verification and immediate discovery of contracts? Also, has there been any thought on how you could create a proof of fiat collateral in a Zen contract? So what formal verification is? Formal verification refers to a variety of techniques used to prove the code matches some kind of specification. So you give some kind of specification for what your code should do, and then you want to prove that it implements that specification. So this is different to testing, in that testing only shows that it's correct for the cases that you tested, whereas proving something, you can prove it for all possible cases at once. So how it creates verification and immediate discovery of contracts, I don't think this is really related. Formal verification is a security measure that you can prove that something matches its specification. So, for example, if the parity multi-sig wallet was properly formally verified, they might have tried to prove that that only the correct people are authenticated to suicide a contract in Ethereum, rather than just testing whether or not certain people could. So formal verification is about making sure that you're not vulnerable to certain kinds of bugs and being able to show to other people a proof that the behavior of your code is matching some kind of specification.
Yeah, that's actually how we get... sorry.
Go ahead.
Yeah, if you're looking at discoverability of contracts or of assets, that's one way of doing it. If you want to discover only let's say, a call option that actually has a certain amount of collateral, then one way of doing it is to scan or look for contracts that carry a proof that they have enough collateral and that they implement like the properties of a call option correctly. And that's the sort of thing that we're looking at doing on Zenprotocol.
So the second part of the question that wasn't answered, I think, is also, has there been any thought of how you would create a proof of fiat collateral in a Zen contract? That kind of thing has to do, I think, with, fiat. So by definition, what we're referring to is things that, aren't in the crypto sphere. They're things that occur in the normal banking system. And, how do you report on that kind of stuff? The way we use that, I want to make sure that people know that, like, essentially we're here. We want decentralization and everything, but decentralization is a means to an end. And we're more than happy to be, pragmatic about, how to achieve our goals. So if in certain cases people want to use fiat collateral, and have like essentially, lawsuits taken against people who don't respect their obligations, I'm more than happy to let, the market decide if that's a good kind of asset, one backed by, the faith that, prosecution. So essentially, how would people know about fiat collateral? Essentially, someone would say, listen, this is backed. Maybe you have a rating system or you have something like that. Maybe even, the bank comes in as an oracle and says, hey, actually this account does hold this amount of money in it. Yeah, that's all I have to think about the fiat collateral.
Okay.
Ash, you want to touch on scalability or?
So how does it solve scalability? Scalability isn't really a problem that has a solution. Eventually, you always hit some point where scalability is difficult. But we do have a lot of stuff that we've implemented to try and improve the extent to which Zen can scale relative to other smart contracting platforms. So our smart contract code can execute much faster than any other platform because we're able to compile our code rather than interpret it. So we're able to process more smart contracts in the same amount of time with the same levels of security. It's an important thing when we're talking about scalability to realize that there are no real limits on how much a blockchain can scale. It's a trade-off between security, decentralization, and scalability. If you don't necessarily care about decentralization or security, then you can scale as fast as a computer can go. Or several computers can go even. But we do care about decentralization and we do care about security. So you're limited to how much throughput you want the weakest participant in your network to be able to handle. So what we can do, we can make sure that we can process smart contracts faster. We can make sure that we can process more smart contracts at once because we can do parallel execution of smart contracts. We can make sure that you don't need smart contracts to move around assets like you do in Ethereum. We have regular transactions to move around assets like in Bitcoin, which is far more efficient than interacting with a virtual machine like in Ethereum. Aside from that, like how many transactions you can do, this is a trade-off with your network topography and how much security you want, how much you want the weakest network participant to be able to do. We've proposed things like non-outsourceable proofs, which are a mining mechanism that would force miners to run nodes rather than the situation that you have now where miners don't run nodes, they participate in pools. So if you can force miners to participate, to run nodes, then you have a much higher degree of network security because you have more nodes. So when you have more security, you can take measures that may decrease your security slightly, like sharding, and scale further.
Nathan, do you have any thoughts to add on that?
Yeah, did we talk about how you can parallel validation?
Yeah, I spoke about parallel validation. So Ethereum is or all other parallel platforms actually are single-threaded virtual machines. They can only execute, say, one contract at once, or if they're doing accounts-based assets, then you have to process all transactions in order, single-threaded. So this is very inefficient, especially because modern computer architectures can support a high degree of parallelism. So in Zen, smart contracts can be executed in parallel at the same time. So it's not necessarily necessary to process everything strictly in order. So we can process many more things at once. So you're not as limited, like Ethereum at the moment is limited by how many computations they can do. If you allow parallel computation, you can do many more computations in the same amount of time.
And there's one more thing, which is that it's something we talk about in the context of contract privacy, being able to do a contract without revealing everything that's in the contract. So we have that, and you can look at that in our white paper. But the side effect, if you like, is that you don't have to do all the computation on the blockchain either. So if people aren't doing all of their computation on the blockchain, then not as much stuff needs to happen on the blockchain, and you can have a higher throughput. That's the other thing that comes to mind as far as on-chain scalability of Zen protocol.
I'd like to add my thoughts here, which is that, when you talk about scalability, you have to address it in different vectors. So, there's scalability for, let's say, users, nodes, miners, etc. And then there's the scalability of what actually is going on, which I think people usually are referring to, which is nodes. So essentially in nodes, you're looking at like, what's the size of the database that they have to be holding? What's the amount of bandwidth that they need to be able to have, internet bandwidth to be competitive, and how much computation do they need to be able to do? Now, I think it's very important for people to keep in mind that scalability in blockchains is not really an issue. I think that's a very underestimated thing because, essentially Bitcoin has a scalability issue due to politics and not due to, let's say, actual issues, in my opinion. And Ethereum has a scalability issue because they essentially, combined a few bad design choices, essentially the fact that it's a single-threaded process, the fact that for each operation, there's another few operations that have to be done to count gas, the fact that you can't parallelize these computations, and on top of all that, the fact that essentially that, you have very low block times has resulted in like some sort of a bottleneck in Ethereum. Now, with us, essentially, so I guess what I'm trying to say is, in general, I think scalability is kind of a red herring. It's kind of a buzzword right now. But essentially, even if you do look at scalability, so on our end, then there's a few things, and I think we kind of address all these things. When you're looking at like how much data do the nodes need to hold, that's the kind of stuff that the active contract set assists there. When you're looking at how much, like bandwidth do you need to have, that's where non-outsourceable proofs and a good network topography comes in and helps. And if you're looking at, how much computation can the nodes do between, receiving blocks, etc., that's the kind of thing where Ash already touched on, parallelization, compilation, not having to do multiple operations for gas, etc. So yeah, those are just my thoughts on scalability. Nathan, would you like to take the next question?
Next question is, next step after, when will the coin be ready to trade? We're not talking about trading. The coin will be liquid when we release our Genesis block next year. And we're trying to get that out as fast as possible. And we have said second quarter of 2018, we're going to try and step up the pace and have a stable and secure mainnet as soon as possible, before then, if possible. Okay. Next question, Adam?
I'll take the next two questions. So first is, do you guys see Zen as a financial revolution? Personally, I've been involved with Bitcoin since 2011. When I saw it, I thought that, this is going to be a great thing because it's going to remove the ability for, governments to essentially inflate currencies. And when I look at Zen, I think, I guess a large part of the motivation behind Zen is realizing that, Bitcoin should be gold, but it won't, but, people want to hold things that aren't gold. They want to do transactions which aren't just, in the intermediate commodity, if you so will. And essentially, I think that either Zen or some competitor to it must be a financial revolution. I mean, I just don't see any plausible outcome where, my grandkids are, having a bank or having a third party, holding all their money for them rather than holding it themselves. Just like I don't think that, if you were like in the French Revolution, I don't think it would be plausible for people back then to think that, that you wouldn't have freedom of speech or human rights back then. I think it's quite like granted and given that, people are going to seize control of their assets, and, maybe we're the ones there and we're the ones that, that leverage this shift and this effect, and maybe we're the ones that don't. And that's, that's just part of the risk. Algorithms are kind of like a meme, but the thing is, necessarily that Sorry,
guys. What's happening? Adam will try and get on as soon as possible. Just about. Just a second. Yeah.
Okay, so whilst Adam fixes his technical issues, I'll answer Daniel's question: how is Zen's Oracle solution different than Chainlink's? So before answering this, I'd like to say it's we don't really like to compare ourselves to projects that don't have a working implementation yet. It's a silly thing to do. Like, how is Zen's Oracle solution different to a magic genie that does whatever you want? If you don't have something real, you can't really compare it. But I have read the white paper, so I can comment somewhat. So Chainlink's solution for oracles involves heavy dependence on Intel SGX. Very quickly, if anyone wants to Google Intel SGX bugs, there's plenty, and they're very hard to fix because they're baked into hardware. So when you're depending on something with known bugs, you're depending on something to be secure, even though we know there's bugs and we know that they're not being fixed, is terribly irresponsible. Maybe Intel will fix them somehow. Maybe Chainlink will actually develop their Oracle solution. Maybe. Aside from that, you are really relying on a lot of properties about Intel SGX that are maybe aren't unwarranted to trust in the first place. Whether or not it is actually possible to get high enough security guarantees from SGX is very much an open question. It's not a widely used system. It's not in any way open source. We don't really know how it works necessarily. It's a very strange thing, even if they do get it working.
Hey guys, sorry about cutting off. Yeah, back now. For some reason, the internet today is especially spotty. Usually this is not the case, so my apologies. Essentially, we were talking about multi-hash mining, so I started to say, I feel that a lot of the coins use mining algorithms as kind of like a meme. Essentially, everything isn't motivated by, necessarily better miners. It's the economics of it. So essentially, when Satoshi started the system, there was this assumption, right? The assumption was that like hash power would be a good like proxy for, the users of the system. And as time has gone by, obviously, you've had pools and you've had ASICs and you've had a situation where maybe you have a few people who control the majority of hash power. So you can no longer, like, essentially we've seen with the whole forks and the whole like politics of the past few years, where essentially, the community, I think, feels that hash power alone isn't a good way to vote on, what should or shouldn't be done. But that leaves a situation where, how do you make decisions and how do you incentivize people to act appropriately? And another problem we also saw was essentially, how do you essentially make miners do what the users want? Now that you see that the miners aren't necessarily the users, they don't necessarily reflect the views of the users, how can the users make sure that the miners are like compliant with their wishes? And that's what multi-hash mining does essentially. It says, listen, we're going to have, multiple miners, multiple different hashing algorithms. And if, let's say, the SHA-256 squared miners, essentially Bitcoin miners, don't listen to us, then, we can penalize them and reduce the amount of blocks, the amount of money they make, give more money to the Ethereum miners, etc. And the way that this is done is by a coin vote. So essentially combining these two things, you both get the voting mechanism, which like Bitcoin kind of missed out on, but also it's not a direct voting. It's kind of like a electoral democracy kind of voting. And you also result in incentive compatibility between the miners and the users. So that's the point of multi-hash mining is essentially the fact that it answers economic requirements rather than technical ones, or more, I'd want to say mechanism design and game theoretic requirements. And a nice side effect of this from the technical level is that you can get a very strong network because you can have multiple chains merge on your coin. So you can have the mining power of Bitcoin and Ethereum combined, kind of like build it on top of each other. That's it. Sorry for being so long. Ash, you want to take the next one?
Sure. So how can we scale or be fast enough to avoid problems in Ethereum like CryptoKitties?
No. Is that an Oracle solution?
Or we did that one.
No, I answered that.
Sorry about that.
So on CryptoKitties, first, we'd like to encourage those Zen only be used for serious applications. But we know that some people might use it for other things. People can use it for whatever they want to, if for some reason they do want to make CryptoKitties. So the problem in Ethereum with CryptoKitties isn't actually that CryptoKitties is computationally intensive. It's that when CryptoKitties is happening, other people can't get their transactions through at the same time. And so Ethereum has to do everything in order. So because we can process smart contracts in parallel, if you were to do something like CryptoKitties on Zen, CryptoKitties might use up a lot of computation. If it's very popular, that's fine. But you could also process your other computations at the same time without having to worry about CryptoKitties using up all of the network's processing power. So if I wanted to do something like, say, Ether Delta on Zen, you wouldn't have the situation where you can't use Ether Delta because people are busy trading CryptoKitties. You'd be able to use Ether Delta and CryptoKitties at the same time.
Okay, next, so we're well aware and apologize about the concrete walls. Nathan, you want to take the next question, integration with ZEC, Zero Cash?
That would be, yeah, Zcash, right? We can integrate with anything using an oracle, any blockchain. If you have a beacon that says what are the headers in a blockchain, then we can see what's going on there. If you're talking about integrating privacy features, like Zcash's zero knowledge proofs or that sort of thing, that's something I'm going to hand off to Ash, because he is better read in zero knowledge and privacy oriented systems than I am. We do want to have anonymity. Our architecture is better oriented to allowing you to have privacy over what assets you control, because we're coin oriented. So having a particular coin is a simple thing for us, and that means you can effectively be part of a large set of other people who also have that coin. But yeah, for the rest about zero knowledge and privacy, I'll pass this question to Ash.
So privacy is a very important.
Ash, before you continue, I just want to say I received a comment on a personal medium that we're talking way too fast for people. So let's try to lower the pace.
Sure. Sorry, guys.
Okay. So privacy is a very important feature, especially if you're talking about trading financial assets. Now that we have exchanges giving up people's trade records to authorities, it's very much a concern. People very much want to be able to hide the transactions they make. Now, there are several different ways to do this. There are several privacy coins around at the moment with different mechanisms, things like Monero, Zcash, Zcoin, which there's plenty of different ways to do privacy. An important thing in Zen is that we have an idea of first-class tokens. So any token in Zen works very similarly to something like Bitcoin or Litecoin, any kind of UTXO-based coin. It's not like an accounts-based system like in Ethereum. Because you have a very traditional mechanism of tokens, you can apply a lot of these security measures to something like Zen Protocol. We're very much interested in implementing privacy solutions. We haven't committed to any in particular yet. We're still reviewing. We want to be sure that we have very strong privacy and we don't make any mistakes if we're putting in privacy features.
Yeah, can you hear me now? Yeah, okay. Obviously, Bitcoin, has smart contracts, but usually when people refer to smart contracts, they're referring to it in a capacity which means essentially, greater than what Bitcoin offers. So in that capacity, what we should say is that essentially, we're the first to essentially solve smart contracts without a virtual machine. Our main, scientific contribution here is using formal verification to be able to get rid of the gas system. And what that means is that essentially our architecture is very similar to all the technical progress that's been made, whatever it is, Zcash, Monero, et cetera, These are all built very similar to either that forks of or inspired by, the Bitcoin code base. And therefore, it's very easy for us to assimilate those features into us. Whereas when you're looking at something like Ethereum, which is a from scratch kind of thing, they have to reinvent the wheel, everything for themselves. They're kind of like rowing on their own. So yeah, that's a major benefit that we get from our architecture. It's not only about privacy. Privacy is the big thing because there's a huge amount of effort to figure out how to do zero knowledge proofs. So it's not something quick to be done. But in general, both zero knowledge proofs and things in the future are very easy to assimilate over from existing technologies. That's it.
Okay.
Should I? Okay, the next one. Nathan, please go for the next one. I think we covered that. No.
We did. Real world use cases. I think that was the first question I circled. So, and then you dealt with Bitcoin as a decentralized community-run project and the CEO question. Adam, did you get to actually? You did come back and complete that question, right? So,
yeah, I believe so.
To the real world.
Yeah. Yeah. So I'm sorry, Crypto Chef. I will address those questions in private. My apologies, man. We really love you, but yeah, I don't want to bore our viewers. So I think the only one we didn't cover out of these questions was number 4. So essentially, would we consider setting up a Zen Protocol development fund where you help other people and projects build dApps on Zen Protocol to accelerate the ecosystem? So I'd say the answer to that is a few parts. Number one, Definitely a lot of the resources, some things, essentially some things are, kind of like an iffy thing. It doesn't like either, I'm talking in generalities here, so my apologies, but essentially, some things, for example, like can we get rid of the gas system and still have, like loops and recursion? That's not a question of money, right? That's a question of like, you need some money to get it done, but is it technically possible or not? Other things like, very good documentation, very good APIs, very good SDKs, very good, development tools. That is a question of money. And the more money you have to throw at it, the better they can get. So the first part to answer is, are we going to help develop like other projects and to facilitate people using our ecosystem is definitely yes. We want to take all the funds we have and allocate them to make sure that, it's very, very easy to use Zen, to build on Zen. And then the second part to that question is, would we personally finance it? I have to say that that's a question that we do not have an answer to yet. There's a lot of, questions and moral, legal, et cetera, what should be done, what shouldn't. Actually, yesterday was, I've gotten concrete propositions before, but yesterday really like someone was really pushing it forward with numbers and everything. And, I don't have an answer to that. We don't have a policy yet. I think that so long as it's, a small amount of money that's, reasonable for the project at hand, it's strategic to, us accomplishing our objectives, we should be very happy to allocate funds to that. I don't want any like kind of nepotism or that kind of thing going on. And I also recommend, with multi-hash mining, the future 80% inflation, that's up to the community to decide what to do, right? They can allocate all of it to miners. They can allocate, let's say, only 70 out of the 80% to miners, and they can put 10% in some sort of, project fund that is controlled by, the community for that purpose. So essentially, if there is like strategic demand for that kind of stuff, and yeah, I recommend that the community go ahead and do like a DAX style thing if they think that that's appropriate. Last thing I want to say is, Ash and Nathan, please feel free to, if you want to comment any further.
Only to say that the advantage of being able to independent talent and people who are doing their own stuff that is good for Zen and so on is so great that we have to do stuff to encourage it. But we really want to learn from the example of other blockchains and projects that have allocated set amounts of percentages of funds and so on. We don't want it to turn into something that it doesn't need to be. That's it.
Okay, 1 second. So let's go back, please, to the to the questions here that we've received previously. We only have a few more minutes left, so essentially, one of the last questions we should cover is how many transactions can we process simultaneously, as we previously covered. That's essentially a question of, that's kind of a red herring. Essentially, there's no such thing. You have to measure it for like what's the weakest link in the network. So essentially, one computer can process as many as it can, for that. Let's say, what kind of a CPU is it having? If it has a cell phone CPU, that's going to be a lot less than if it has like a Threadripper, a crazy gaming computer or a server. So that's about that. But with regards to transactions per second, the real question is how much can you process without making it uncompetitive for someone to still use a network, to essentially service the network. And the answer to that, it's like a multidisciplinary thing. It's between the non-outsourceable proofs. It's between the fact that each node individually is essentially can process more from a CPU perspective, but also from a bandwidth perspective, et cetera, et cetera. That is a long answer, and I actually think that probably justifies a written answer that we should formally put out there, because I know a lot of people are interested in that. So definitely, within the next few weeks, or if not after the sale, I will write such a thing, or someone from the team will. Next question we've got here is, other coins like BCH or LTC are plans to integrate with them. I want to make my personal opinion here clear, which is that, I personally am a Bitcoiner. I want to see Bitcoin succeed. I don't think that, Bitcoin needs to change itself to whatever the flavor of the month feature is, if it's scalability or smart contract or blah, 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 blah. I am a proponent of Bitcoin scaling both on and off chain. But definitely it's got to scale. But I'm sorry, I'm going on to a tangent. The point is, like, this is a project to help out Bitcoin. But if there's a demand for it to do other things, it's also a project that's here to help out finance. And if we see that, at the end of the day, there is a demand for it, I guess, like someone previously asked, is it a community project or does it have a CEO? And the answer to that is, at that point in time, I think it would be a community project, and it's going to be whatever the community decides to do with it. Yeah, those are my thoughts on it. If anyone has anything to add, I'd be happy to. But besides that, we only have time for one more question, which is Ether Delta versus our version of decentralized exchange.
Yeah. Okay, I read a question. If I wanted to write Zen for Delta DEX, could you explain how one could do so in some easy to digest steps? So there are a few steps. If you wanted to do Ether Delta on Ethereum, first you have to define what's a token. What does it mean to hedge or have collateral of these tokens or have a portfolio? What does it mean to swap one thing for another? These are all things that you would have to sort of implement in Ethereum. The Zen protocol system is a bit different. You already have the tokens. So when we're talking about Ether Delta, we're talking about tokens that people have already made, derivatives or things backed with real assets or backed with cryptocurrencies. That stuff that is already out there, and people are sending it to a coordinating contract that is going to manage these exchanges. And obviously, I can't describe every single step in writing a decentralized exchange. But the key points are that it's about achieving, just like a blockchain is about achieving consensus on trades. Well, so is this. It's about achieving consensus on trading one thing for another thing at a particular price based on some order book. And that is the sort of thing that our smart contracting language is designed to make possible to do securely. We understand our contracting language, understands tokens, it understands the idea of the authorization to trade a token under certain conditions, and it can even put this stuff off-chain with on-chain backup. So it's one of the things we want to have on our chain, an exchange, a decentralized exchange, and we think we're in a pretty good position to put it there.
To add on that, something like Ether Delta is slightly limited in that you're only exchanging tokens. This isn't a real exchange. Real exchanges have much more interesting products than just being able to trade assets. You can actually trade derivatives. And this is something that Ether Delta is not handling because it's relatively difficult to create derivatives for Ethereum assets due to its architecture. It's fairly difficult to create generic assets, generic call options, generic put options, for example. So that's something that Zen protocol really excels at. If you already have an idea of an asset, it's very easy to create derivatives on that asset, and that's very important. If you have a decentralized exchange, you could actually have a much better decentralized exchange on Zen protocol. You could have much more interesting assets. And I think there is actually a huge gap in the market at the moment, in crypto at least, for more interesting financial products on crypto. Like, personally, I would definitely trade using something like a put option. When you see something like a pump and dump, you want to be able to short or create a put option, and you don't really have these assets being offered on something like Ether Delta. So I think definitely it's a strong application of the decentralized exchanges.
I'd like to add one more thing. Yeah, so essentially, in Ethereum, right, because it doesn't have support for these tokens at the level it's all ERC20 contracts, if I want to do like a token, an ERC20 for ERC20 contract swap, well, that becomes a very difficult process, right? I need my contract to be able to take an action based on another contract, and these contracts have to be aware of each other, et cetera, et cetera. That's why you actually see that Ether Delta is always like ETH versus, another token. Because it's a lot easier for a contract to say, okay, I've received Ether, now I'm going to, move this balance. That's something easy. But to say, I'm going to observe this other contract, if it moves its balance, I'll move my balance. That's already a lot harder thing to do. More expensive also computationally and in other manners as well. So essentially, with us, it's kind of like all the tokens are like Ethereum. So essentially, like Ether is in Ethereum. So, I can say I'm going to send you Zen for let's say Alpha token, right? And that would be as easy a contract, the exact same contract actually as, Alpha token for Beta token. So that's a very important point to put out there. And that's going to result in, and you're going to see like this increasing amount, I think, of interchangeability in these tokens and contracts. So let me give you another example here, which is take, let's say, an ETF. So I'm going to say, okay, if I give you now one token, right? I'm going to give you one ETF token. Let's call it the S&P 500 token. And you're going to give me back the 500 stocks, right? The 500 stocks which compose that ETF. So if you were to imagine this thing to go on Ethereum, right, would be pretty much impossible. You'd hit the gas limit. But let's even say you wanted to attempt it, right? So okay, you're going to update the balance of the ERC20 contract, which represents the S&P 500 ETF, right? You're going to move, it's going to change its internal balance. And then, it's going to essentially request that another 500 contracts change their internal balances. But so that's obviously going to be very hard to work when you're looking at, what I'm going to do is I'm going to send, one token out, and I'm going to just get a transaction which sends me 500 tokens back. Very, very simple, very straightforward. So that's essentially, a very good example. I'm sorry for the plug, but where you can really see the technical architecture here shine when we're discussing things like decentralized exchanges or anything for that matter, which uses tokens in general. Yeah. Okay, guys. Is everyone here satisfied? Nathan Ash?
Right, there's one thing I want to say about the.
Yeah, go ahead.
Sir? There's one thing I want to say about Ether Delta and that stuff. Ash provoked me. There's a lot of stuff that that I've heard about doing on blockchains or doing that hasn't come to pass. Even stuff that's got a very immediate financial application or immediate social application. So, for instance, the markets that we see right now, where it's on Ether Delta, it's one thing for another, one thing for Ether, and we can say, okay, we're doing one token for another much more easily, which we can. But what if you have some more complicated preferences? What if you had, if you wanted to do, if you wanted to reach agreement with people by trading in a market on some course of action? That's something that has been described and that you could do, but you haven't done it in a blockchain yet. I want to see applications on a blockchain that can extend what's possible to do financially, what is possible to do in the world of finance. New financial solutions. I'm talking about things like combinatorial markets or Futaki and stuff like that. And I really hope that we see that sort of application.
I'm sorry for cutting you off, guys. I just noticed that very happy to say that we just reached 9 million sold, so 3/4 of the way through. So thank you very much to whoever decided to contribute right now.
Yeah, thank you, guys.
Appreciate it. Yeah, sorry, go ahead.
No, that was it. That's what I wanted to say. New sorts of financial application that don't exist now, but that become possible when you're working in like a blockchain, a decentralized consensus system.
Okay, guys. So I guess if that in that event, okay. So yeah, I think that we're pretty much done, and we'll be in touch. Thank you very much for taking the time. I know that there's definitely we lack bandwidth right now, and we're trying to get better with that. So definitely if there's another question, feel free to post it. in our Telegram group, or if it's a very technical question, feel free to send it to, or even if it's not technical, but if it's one that requires like a personal response, please feel free to directly message myself, Nathan, or Ash. I think our users are in the pin post. That's it. Thank you very much, guys, and have a good day. Bye.
Bye.